Well, hello. Today we're going to continue talking about probability by looking at something called the odds. Now, the odds aren't necessarily talking about like evens and odds, not that kind of odds. The odds here are things that it deals with a probability, the likelihood of something happening compared to something not happening. And this is actually a pretty common thing that you would have heard mainly in one or two areas. Now, if you've ever been to a racetrack and you've bet on horses or something, like that's where you hear about the odds, like oh she's a 7 to 1, or a three to four. And then also in Las Vegas, whenever they talk about gambling, there's a lot of the odds, like especially on a craps table, things like that. So those are a lot of places where you'll hear odds. Um, Primarily with gambling. Okay, so let's go ahead and take a look and explore a little bit about what these are, because the numbers that you get are slightly different than you do with probability. Okay, so the odds, it's actually a ratio of the probability that the event fails to the probability that the event succeeds. Now, that specifically is the odds against something happening, because in a little bit, we're going to look at the odds in favor of something happening. So all we've got to do is find the probability that something fails, and you're going to divide that by the probability that it succeeds. Okay, so the probability of failure divided by the probability it succeeds. That's what the odds against are going to do. Then we'll write it using a colon. So let's take a look at one. Find the odds against rolling a 6 on a die. Well, we know that on a die there's 6 sides, so 1, 2, 3, 4, 5, 6. The probability of rolling a 6 is 1/6. The probability of not a 6, that's the rest of them, it's the complement, is 5/6. And so if we want to find the odds against the event rolling a 6, then we would notice that we put 5/6 first, okay? Because we're going to put the probability of failure divided by the probability of success. That we fail, that we don't get a 6, that's 5/6. That we succeed is 1/6. Okay, so we're going to take 5/6 divided by 1/6, and then we're dividing fractions, and so a lot of people learn it with this keep, change, flip thing, where you keep the first one, change the sign to multiply, and you flip the second one. Okay, we cancel, we get 5/1, and then we have to write this using a colon, right? So we're going to say 5:1. Okay, that's what the odds are. So the odds against rolling a 6 are 5/1. Now, there's another way to do it, and this is the way that I really like to do it myself. And it doesn't involve so much probabilities as it does just counts. So if you find the number of successes and the number of failures on a die, that's kind of weird, then the number of sixes that we get, there's 1. The number of not sixes is a 5. I don't know what's going on right here. That's weird. So now the odds against rolling a 6 is we just do it like this. We would say not sixes, colon, sixes. So how many not sixes are there? There were 5 of them. So we would say 5, colon. How many sixes are there? Well, there's just 1. And then what you do need to do is look and see if these have any common factors, if they can be reduced at all. And honestly, that's where the probability side of it comes in, makes it a little easier with like dividing the fractions, because it's just a natural thing to reduce those fractions. Whereas, if we had come out with something like 10 to 2, you don't want to list that as your final answer. However, they do both have a common factor of 2, and so you could divide that out and turn it into 5/1. Okay, let's look at a couple more. Find the odds against rolling a number less than 3. Well, there's 2 numbers that are less than 3, right? Because if you think about 1, 2, 3, 4, 5, 6. So we have 2 numbers that are less than 3, and we have 4 numbers that are more than, or that are greater than or equal to 3. Okay? So the odds against rolling a number less than 3. We get 2 to 6, and then we get 4 to 6. Now, this says the odds against, so that means we want the failures first. So we would use 2/3 or 4/6, whichever, right? So you'd use 2/3 first, take 2/3 divided by 1/3. The second one, the failures divided by successes. That comes out to 2 over 1, and then you would write that as 2 to 1. Now, the other way to do this, like I said, the way that I typically do it, is I go by the counts, right? So we have 2 numbers that are less than 3, and we have 4 numbers that are not. And so I would just write this as 4:2, right? We have failures to successes. And then I see, well, they're both even, so they can be reduced down a little bit. I could take a 2 out of each of them, 2 to 1. I think this way is a nice clean way, but this is kind of a nice little way of making sure that your odds are reduced all the way. That's the nice part about the fractions. Okay, last one here. 500 tickets are sold for a lottery in which a single prize is awarded. Now, this means that it's going to be like a raffle ticket. So you're guaranteed one winner out of these 500. It's not a lottery like the Powerball. Okay, that's not that kind of lottery. All right, determine your odds against winning. You'll notice each time I go through and identify the fact that it says odds against. That's very important because in just a second, we're going to go to the odds in favor. And it's going to be just backwards, okay? So determine your odds against winning if you purchased 10 tickets, okay? So here's what it looks like with probabilities. Let's go through and just talk about it how I kind of think about this. Determine your odds against if you purchase 10 tickets. Well, we have, so we have 10 wins, right? And we have, not wins. We would have 490 tickets that could be drawn in which we would not win. Right? So out of these 500 tickets, if there's 10 of them that if they drew that ticket, then we would win. And there's 490 that we would not win. So if we want odds against, remember in this case, that's going to be not win, colon, win. So that's 490, colon, 10. And you can write the word 2 if you want, but I just like the colon. And now I see that they're both a factor of 10. I could divide a 10 out of each of these, and that's how you end up getting this number down here of 49 to 1. If you divide a 10 on the left side, divide a 10 on the right side, you end up getting 49 to 1. Okay? All right. Now, the odds in favor, notice there's only one difference. Look, if it's odds in favor, you're going to put successes on top and failures on bottom. The only difference is that the numbers are switched around. That's it. That's the only thing that's different about this. Okay? So let's actually go back to the last example. If this one had said, determine your odds in favor of winning, then that would be 1 to 49. Because it would be the number of wins, colon, the number of losses. So that's why it's so important to identify whether you're doing the odds against or the odds in favor. If you're doing against, then it's losses first. If you're doing in favor, then it's wins first, right? It's the favorable ones first. If it's against, it's the ones that are against you. Those come first. So it's not that hard to remember. You just have to be very, very careful with it. Okay, let's look at one last example with this before we move on. Find the odds in favor of rolling an even number. So we have in favor. So that means that we want wins, colon, losses. That's what our answer is going to look like. It's going to be that. So then we're going to have evens are going to come first, and then not evens are going to come second. So here's a nice way of doing this with probabilities. You would take the probability of getting an even, that's first, divided by the probability of not getting an even, that one comes second. Then you keep the first fraction, flip the sign, or sorry, change the sign and flip the second one. Okay, I always think of it as just multiplying by a reciprocal. That gets you 1 over 1, or 1 to 1. Now, if we were doing this kind of my way, where we were doing the counts instead of the probabilities, we would have 3 evens, and we would have 3 not evens. So if we have 3 evens and 3 not evens, well, a 3 can come out of both of those. Hopefully you see that easy enough. And that's where this comes down to just be 1 to 1. Okay, 1 to 1. This is what you might call even odds, as weird as that sounds. It means you're just as likely to win as you are to lose. Okay, now that might seem weird because most of us are used to probabilities, like 1/2. You'd say, oh, well, you have a 50% chance of winning. You know, why does this say 1 to 1? Well, again, it's because it's a number of wins for every number of losses, or compared to the number of losses. So 1/2 probability equals 0.5 equals 50%. Those are all equivalent ways of saying this 1 to 1 odds. I know it's weird. That's one of the reasons we don't use odds much, is because people are just used to probabilities. Okay? I don't know. There's probably other reasons why, but probably because the calculator doesn't give you odds, it just gives you probabilities. Okay, so given the odds of an event, we can work backwards. If you go back and you think about that horse race, or you think about playing on the craps table and you see the odds on the craps table, you can work backwards on what your probability is. Okay, so we know that if we have, if we're doing odds against, then we would say, oh, well, that's failures to successes. So if I have some event where I have 2 failures and I have 5 successes, then that would mean that there's 7 total attempts, if you will. Okay, you could that's just the best way to think about it. If you have 2 failures and 5 successes, 7 attempts. If we were doing the odds in favor, remember, odds in favor would be successes first, then failures second. So, and this is a different example. I hope you see that. Let's just say that we have some event where we have 7 successes and 5 failures. Then that means that there will be a total of 12 attempts. Okay, and we know that probability deals with the number that you want divided by the total amount. Okay, so if the odds against something happening are 8 to 3, then the first thing that I'm going to think about is, oh, 8 plus 3 equals 11. There were 11 attempts. Now, if I want the probability of success, I'm going to take the number of successes and divide it by the number of attempts. Hence, if the odds against are 8 to 3, then the probability of a success is 3 out of 11. Okay? Now, the probability of a failure, well, it's just switched around, right? We're going to take the number of failures divided by the number of attempts. We know there's 11 attempts, and so then we just take the number of failures, which was 8, we divide it by 11, which is the number of attempts. Let's look at our last example here, and we're going to look at the odds in favor of winning a scholarship are 7 to 4. Determine the probability of winning. Okay, so go ahead and pause the video here and come up with the probabilities of winning and of not winning for this particular student, I guess. Okay. All right, let's take a look. So first thing we're going to do, the probability of winning, we're going to find the number of wins and divide it by the total attempts. So I would say 7 plus 4 is 11. So 11 is what's going to go on bottom. And which of these are successes? Well, clearly the 7 is, because I already have it boxed. It says odds in favor. That means the favorable outcomes are first. So 7 is the wins and 4 is the losses. So that means then that there are 7 successes and 11 attempts. So our probability is 7/11ths, or about 64% chance that you win. Now the probability of not winning, well, I actually already know if it's not winning, it's going to be, we could think of it as the complement, as 1 minus the probability of winning, right? We did that in a previous lesson. So I already know the answer to this is going to be 1 minus 0.64, which is 0.36, or 36%. That's the complement rule, right? If it's 64% chance that we win, then it's a 36% chance that we don't. Now, but using the odds and thinking about it that way, the probability of not winning, we would come over here and we'd say, well, there's 11 total attempts, and 4 of those are not wins. So 4 out of 11, or 36%. Okay? So I know odds are a little bit tricky. We don't use them. You're not near as comfortable. Most people aren't near as comfortable using odds as what they are, probability or percentages. We just see those a lot more in our everyday lives. But the odds aren't tricky. They are. But you just got to pay really close attention and realize that this represents a total number of attempts, like 7 and 4 would make a total of 11. So then we look at successes and failures. Please make sure to identify whether the problem is odds in favor or odds against. All right, good luck.